welcome to the last module of design to prevent fire and explosion. So up till now we have studied in different modules about the general design consideration to prevent the electrostatic ignition. What is the concept of relaxation, how it is beneficial to the process industry. We have discussed about the bonding and grounding and how you can implement all those things into the process industry. The concept of dip pipe, advantage and disadvantages. We have discussed about the increased in conductivity with different additives so that we can prevent the hazard of electrostatic spark. We have discussed about the explosion proof housing so that we can prevent the hazard by cardoning of the explosion prone equipments. We have discussed all aspects of ventilation, and in this particular module we will discuss about the different aspects of sprinklers. So let's have a summary about the sprinkler system, what we have discussed in the previous module and what we are going to discuss in this particular module. We have discussed about the wet pipe sprinkler system, which uses the water that discharges through the opened sprinkler via heat. We have discussed about the dry pipe sprinkler system. They use usually nitrogen or air under pressure. In this particular module, we will discuss the deluge type of sprinkler system and how to open the sprinkler with an unfilled water line and only open when a fire or high temperature is detected. There are certain pre-actions of these sprinkler system, this type of dry pipe system with a specialized valve which got triggered by FTS, more sensitive to the fire than sprinkler heads. Now there are certain water mist system. They are usually similar to the automatic sprinkler system in all aspects except the application of water for a sprinkler. So you can see that as the name suggests, use water mist which actually absorbs the heat, dislocates the air or oxygen or hinders the radiation of heat. So by the formation, because these mists they are having the larger surface area so that they can easily absorb the heat, and simultaneously because they are having the large density, so they can cordon off the air supply and indirect way the oxygen supply, and simultaneously they hinders the radiation of heat. So they use specifically for a small confined area such as inside the equipment enclosure or a cabinets. Because of certain operational difficulties, we cannot use these water mist to the larger area or entire the plant. Now these are the typical systems of water mist system. This is the usual device of water mist system, and this is the operational one. So you can see that the water mist they are coming out from this nozzle. Now the question arises that how to install the sprinkler system. Now you must identify that what are the basic requirements for those sprinkler system. So usually there are four type of requirement for the sprinkler system. One is the position, location, spacing, and how to use the sprinkler system. So first thing is that you need to determine that the protection area of coverage, that how much area you need to cover in the sprinkler system because of certain inherent limitations of those sprinkler system. You need to classify that particular area in question. Then you must design and you must know that what is the maximum and a minimum distance between these two sprinklers, because every sprinkler is having its own efficiency or its own domain. So you need to find out so that you can cover the area in question properly. Then you need to find out that maximum or minimum distance of the sprinkler from the wall. So because you have to prevent certain dead zones, so that's why you need to find out this distance. Now there are certain system protection area limitations, because you cannot install in certain sprinklers in certain area where the things are more difficult to control. Then you need to find out that what are the different applications which are applicable to various sprinkler types, because in the previous modules we have discussed different type of sprinklers. So which kind of sprinkler is applicable to what? So you need to find out all those things. So these need may vary depending on the type of the system, what kind of system you are using. So these are the need, whatever need like position, location, etc. These needs may vary depending on the type of the system. For any system, pre-lubed grooved coupling are always recommended. Now there are certain requirements which are attributed to the wet pipe sprinkler system. They must be reliably heated, and proper heating control must be there so that they can work efficiently. Overhangs and chases on the exterior walls cannot be trusted because of application of heat or repeated use. Sometimes they are not reliable. So that's why you have to take care all these aspects. Normal black steel piping is better for wet sprinkler, but sometimes chlorinated polyvinyl chloride CPVC pipes are generally used. But sometimes if the heat content is on the higher side, then this particular thing is disadvantageous. There are certain facts about the sprinkler. They are recognized as only effective method of fire control. Obviously, because are very much apart from the ventilation, the sprinklers are recognized a very effective methodology for the fire protection. Chances of accidental discharge are remote because they are very sensitive towards their control methodology. Installation cost is very small related to the building cost, and usually approximately 1% attributed to the sprinkler cost. So same as the cost of you can say the new carpeting in a structure. So nowadays buildings are constructed with the pre-installed fire sprinkler system. Even you can find all those sprinkler system in the parking arena, in the other arena which are open to sky, etc. So that you can have a proper protection because of the I mean they are very good in terms of a cost factor. There are dry pipe sprinkler system requirements which they are very, I mean you can say the specific requirement are attributed to the dry pipe sprinkler system. They are gridded dry pipe system, they are usually not allowed. Initially filled with nitrogen in pipes. Now air should be supplied directly from a source which can be accessible all time, and pressure should be maintained throughout the year, and a gradual check of this pressure is always advisable. Dry system should be drained completely to minimize the corrosion. No roll groove ends. Galvanized black steel pipe is used, and use accelerator only when necessary. So these are the certain requirements for the dry pipe sprinkler system. So once you installed these sprinkler system, there is a requirement of inspection, testing and maintenance of those sprinkler system, and there is a regular protocol of this type of thing. So you need to go for periodic inspection, testing, maintenance, which is essential to ensure successful performance of the system when they are needed. Because sometimes it may happen if you are not performing all these protocols regularly, then at the time of need they may fail. So they may not be in a position to provide the adequate support which is required and which is for they are installed. So maintaining adequate system is a critical as the original decision to install the system. It is always advisable that when you are taking the original decision to install all this system, you should follow the proper maintenance protocol. Now, as these suppression detection and alarm systems are generally not used on a routinal basis, their stage of readiness is not immediately apparent, because always we people always busy in the regular process protocols, process working. So usually we do not have much time to pay attention of all these aspects. So that's why it is not the part and parcel of the routinal basis, but we must follow these protocols. Now let us have a look about the inspection. So, visual examination of the sprinkler system to verify that it appears to be in the operating condition and free of physical damage. So, you can visually verify, visually you can inspect all these things that they are, whether they are in physically okay or they are slightly damaged in terms of physical inspection. So, visual inspection examination of storage and general environment surrounding sprinkler system. So, you have to be careful about while performing these physical examination. As far as the sprinklers are concerned, they must be inspected from floor level annually, but it is not necessary that you perform this exercise annually, sometimes 6 monthly, quarterly, etc. That is purely based on the requirement. Installation should be as per the proper orientation of the building, that is mandatory requirement, because sometimes you may forget some dead zones where the vapor cloud explosion or unconfined vapor logging may be there. Should be checked for any leakage in any fitting, that is mandatory. Should be free from any type of corrosion, foreign material, paint, physical damage, because they may create a future problem during the operation. So, you must ensure yourself that they should be free from any type of these difficult scenarios. While considering the pipe and fittings, they should be in a very good condition. Obviously, it is prima facie requirement. They should be free from any kind of a mechanical damage, leakage, corrosion, misalignment, etc. Because sometimes all the physical aspect, even maybe the pressure drop may create a problem, even the corrosion may cause the choking in the nozzles, etc. So, they should be free from all kind of mechanical damage. Now, piping should not be subjected to the external loads by material either resting on the pipe or hung from the pipe. So, that is required. The reason is that sometimes because of the sagging, the piping system may get collapsed. So, this should not be subjected to any kind of external load. While considering the maintenance, they require very little maintenance if from initial time proper care was taken off for sprinklers. So, if you have taken very good care during the installation of a sprinkler, then you may require a very little maintenance cost. Replacement shall have an appropriate feature for the uses proposed and also should be of the similar kind as of adjacent one. Sometimes spare sprinklers, never fewer than 6, shall always be maintained on the premises, so that any sprinkler that have operated or been damaged in any way can be promptly replaced. So, this is again a standby arrangement for the sprinkler system. Dry pipe system shall be kept dry at all time. This is the mandatory requirement and it is the part and parcel of your maintenance protocol. Now, there are certain advantages associated with the sprinkler system over extinguisher. Although extinguishers are more in effect if the fire is small and at an early stage, so they are very much popular. In extinguisher, public have to take risk of their lives to stop the fire from spreading using the fire extinguisher. So, you have already seen all these things in the different pictorial diagrams in the previous modules. These extinguisher requires high maintenance and sometimes you need to refill frequently, etc. There may be a chances of injury while using or while they are redundant, then there may be several chances of injury. So, all these disadvantages are neutralized for fire sprinkler system, which are better automatic fire extinguishing methodology. So, if you recall in the previous modules and if you compare with this sprinkler system with the extinguisher, you can find that they are more better compared to the fire extinguisher. Again, when we compare these sprinkler system over alarm system, again there are certain advantages associated with one. The fire alarm system is a passive system. Only warning will be provided after exposure of fire at an infant stage or a very nascent stage. Evacuation program have to be done just after the warning. So only thing is that this is a passive system and you need to follow a certain guidelines because it does not provide any kind of support system to extinguish the fire or to remove any arm of a fire triangle. Whereas in the fire sprinkler system, no such procedure take place. So that's why they are having an edge over the alarm system. Now in a summary, the fire suppression system include a sprinkler system, standpipe system, specialized extinguishing system, and the most common fire suppression system is automatic sprinkler system, because we have compared all these things with what are the different tools available, whether it is a fire extinguisher system, alarm system, etc. We have compared with the sprinkler system. Then we find it that the automatic sprinkler system are more beneficial. Now at the end, we would like to discuss a couple of numericals through which you can understand this particular chapter well, although there are certain things are given in the reference and you can have a look all those things. So as far as the first numerical is concerned, the container consists of a total percent air by volume and also inerted with the nitrogen gas until total oxygen concentration become less than 1.25% by volume. So the container volume is 2000 feet. So you need to find out that how much pure and contaminated nitrogen must be added, assuming the nitrogen contains 0.01% oxygen. So nitrogen is playing a role for inerting media. So while we consider the solution, the volume of nitrogen required QVT is determined by using this particular formula QVT, which we have already discussed in the previous modules. So QVT is equal to V ln C1 minus C naught upon C2 minus C naught. So here if we substitute all the values, because if you go through the previous slide, the container volume is 2000 cubic feet. This is not the question mark, it is cubic feet. So this is 2000, then C1 is 21 and C naught, that is because initially the nitrogen, if you see that initially the nitrogen contains 0.01% oxygen. So it is 0.01 divided by 1.25, and if you consider that the total oxygen concentration become less than 1.25 by volume. So 1.25, again the C naught is 0.01. So it comes out to be QVT is 5660 cubic feet. That is the quantity of contaminated nitrogen added. Now if we consider this, that is QTV, that is the quantity of the pure nitrogen added, we can easily calculate by this particular aspect. 2000 ln 21 divided by 1.25, it is equal to 5642 cubic feet. So by this way you can calculate that how much quantity of pure nitrogen is added to the system. Now let us have a look of another numerical that you need to estimate the capacitance of a person which is 6 feet 2 inches tall, standing on a dry wooden floor. Epsilon R is 1.0 for air, that is this one, and epsilon naught is the permittivity, and which is given that 8.85 into 10 to the power minus 12 coulomb square per Newton meter square, or 2.7 into 10 to the power minus 12 coulomb per volt fit. Now while we are considering the solution, the person's capacitance is estimated assuming the person's shape is spherical. That is purely an assumption, remember, and that is the sphere is surrounded by air. So if you use this particular equation which we have studied in the previous module, C is equal to 4 pi epsilon R epsilon naught R. Then C is equal to 4 into 3.14 into 1.0 into 2.7 into 10 to the power minus 12 into, because 6.17 upon 2. So it is comes out to be 1.05 into 10 to the power minus 10 coulomb per volt. So by this way you can calculate. I mean, sometimes it is unavoidable scenario that you need to go for this type of assumption that the person's shape is spherical. Then you can assume. Although in our day-to-day affair or in day-to-day life, the things are a bit different. So you need to perform the things as per the requirement and as per the formula based. So let us take another numerical example. In this particular numerical example, you need to calculate the capacitance of a subject standing on a surface which is conductive in nature. Now, assuming the separation of individual shoe sole from the floor, that is, the shoe sole is the dielectric of the capacitor. Now, you are given the shoe sole area, which is in square feet, two shoes 0.37 square feet each. Shoe sole thickness is 0.3 inches and a dielectric constant for shoe sole is 3.5. Let us calculate the things. Now, individual's capacitance can be estimated assuming the subject's shoe sole and the floor are parallel to each other. So, considering the case of two parallel plates, so C is equal to epsilon R, epsilon naught A upon L. So, if we substitute the values, that is 3.5 which is given in the problem, into 2.7 into 10 to the power minus 12 into 0.74 and divided by 0.3, 12. Now, it is coming out to be, C is coming out to be 2.79 into 10 to the power minus 10 farad. So, this is the whatever you require in this problem, and we have taken certain values from the previous numerical. Let us take another example that is related to the vacuum purging technique. Now, in using vacuum purging technique to reduce the oxygen concentration within 1200 gallon container to 1 ppm, now you need to determine the number of purges required and the total nitrogen gas used. The temperature is 75 degree Fahrenheit and the container is originally charged with the air under ambient condition. So, a vacuum pump is used to reach the 15 millimeter of mercury absolute, and vacuum is subsequently relieved with the pure nitrogen until the pressure returned to 1 atmosphere absolute. So, let us attempt this particular problem. Now, here Y naught is equal to 0.21 pounds mole O2 divided by total mole. J is equal to 1 ppm is equal to 1 pound mole O2 divided by total mole. So, the required number of purges is equal to Yj is equal to Y naught NL upon NH J, which is equal to Y naught PL PH J. So, ln Yj upon Y naught J ln PL upon PH. So, J is equal to ln 10 to the power minus 6 upon 0.21 divided by ln 15,760. So, J is coming out to be 3.12. So, this is the number of purges. So, roughly 4 purge cycles are required. Now, total nitrogen used is equal to delta N and to J pH minus PL V upon RGT. So, if we substitute the respective values, this come out to be 14.7 minus 0.387 into 1200 divided by 7.48 into 1 upon 10.73, 75 plus 460. Now, this is if you calculate, it comes out to be 1.599 pounds per mole. So, if we consider in terms of total number of mass, so it is 44.77 of nitrogen. Now, this is the entire solution. In this way, we have calculated, we have carried out several examples. Now, if you wish for further reading and if you wish to carry out the further numerical problems, here we have listed various references and you may go through all these references, and especially while considering the numerical problems, you may consider the book by Crowell and Lauer, Chemical Process Safety Fundamentals with Application. So, we may consider this book, and by this way we are finishing up our chapter related to design of prevention of fire and explosion. Thank you very much.